This is clarification on 8-22. When you have an object like this, you cannot have a moment. Okay, all the moments have to be 0, because think about it. If there was a moment, this object is going to start spinning around. The only reason you can have moments, like in beams and things, let's draw a rough beam, is because you ever notice with a beam, usually you're going to have, they're going to be supported in a way where you have a hinge at one end and something usually at rollers or something like that on the other end. That's about what they usually do. Let's kind of sketch this. You usually have something like this, something like on rollers with a flat surface, and they'll have a hinge here. As a result of having a hinge, then you can take moments, because this is going to be fastened down. When you have an object like this, the summation of all moments must be 0. So what I would, if you're faced with a problem like this and you know you have 180 newtons applied here, all you have to do then in this problem would be cut through A, just like they did here. Okay, and you're going to look at just this half of the beam. Well, and you can see here what they did. So you'd have a force of 180 newtons pulling up here, just like this. So what I would do would be I would sum the force, or sum the moments, and I would say call this point A or something like that, point A. Sum the moments at A, and anything goes this way will be negative, so I'd be 180 coming this way times this moment arm, which is 70. This guy here is either cranking down or pulling up, right? So if this wood is pushing up here, this thing has got to pull back down. So it would be minus this F force right here, and I'll draw that coming down like this, times 30. Set that equal to 0. And I get 180 times 70. That gives me 12,600. Move this to the other side is equal to F divided by 30. I divide this by 30, and that gives me 420 newtons. So F is equal to 420 newtons. That's where this value, this is how they get this 420 newtons. Now at this point, there's no moment at A. However, the next thing you would do would be sum the forces in the y direction and set that equal to 0. When I do that, I got 420 coming down. So I'd say minus 420 coming down, plus 180 going up, plus the force here, which has to resist, so we know the reaction has got to go back up. Set that equal to 0. So when we do that, we get minus 420 plus 180. That leaves me at minus 240. So that means FAY must be 240 newtons. Sorry, 240. And if this is pulling up, and this is clamping down, pulling down, then what's going to happen is this has got to pull back up to resist it. Okay, and that's all it's going to be. This object would be pulling back up, so I would have tension in this area here. All right, nothing more than that. There's no moment. Okay, you just keep going back to Newton's law. Summation of moments is equal to 0. This object cannot start spinning around. It has to, and it makes sense. If I hook the drill up at this and start cranking, this object all of a sudden is not going to start spinning around like this, right? All right, hope that helps.